Hello. In this lecture, we'll begin to program. We refer to this lecture as Python as a Calculator because we're going to focus on mathematical expressions. In this lecture and throughout the course, we'll be using idle, a program that comes with the Python installation. Let's switch over to idle now and start programming. This is idle, and the window that we're currently looking at is called the shell. This is where we can try out Python instructions and explore Python's features. This symbol, the three arrow symbols, is called the prompt. Next to the prompt, we will type Python instructions, and when we hit enter, Python will evaluate those instructions. For example, let's type the instruction 2 plus 3 and ask Python to evaluate it. It's important to note that nothing happened until I hit the enter key. Let's look at another expression, 6 subtract 2. And again, nothing happens until I hit enter. At that point, Python evaluates the expression. Another expression could be 7 times 3. So far, we've seen three operators: addition, subtraction, and multiplication. Another operation is exponentiation, and we read this expression as 2 to the power of 5. Next, let's take 4 and divide it by 2. When Python evaluates this expression, the result that we get looks a little bit different from what we've seen so far. The expression evaluates to give us 2.0 as opposed to just 2. What we're seeing here is that Python has multiple types, and two of its numeric types are type int, which stands for integer, and float, which stands for floating point number. This division operation gives us a floating point result. Let's explore a few more examples of division. 5 divided by 2 gives 2.5, and we would expect that 2 divided by 3 would give 0.66666 with 6's repeating. That is what it gives, although instead of an infinite number of 6's, we're limited by the number of significant digits available. So Python has a limited amount of memory to work with, and the number that we get, the result of dividing 2 by 3, is an approximation to the real number. Floating point numbers are approximations to real numbers. Another example would be to divide 5 by 3, and we can see that the result is an approximate result with 1.66666, and the last digit is actually a 7. Similarly, 7 divided by 3 gives 2.33333, and the last digit is a 5. 7 divided by 3 is floating point division, and since floating point numbers are approximations to real numbers, there's some imprecision, and that's what we're seeing here. Python has a second type of division called integer division. So we'll divide 4 by 2 using integer division, and when Python evaluates this expression, it will evaluate to give an int as opposed to a float. When we divide 2 by 3 using integer division, we also get an int, 0. So the way to think about this result is that if we were to rewrite this, we could rewrite 2 1/3 as 0 2/3. And what we're getting back is this whole number part of the result. So let's consider 5 divided by 3 using integer division. And again, the result is 1, a whole number. So we could rewrite 5 over 3 as 1 2/3, and we're getting the 1. Dividing 7 by 3 using integer division, we get 2. So this would be rewritten as 2 1/3. We're only getting part of the result when we do this, part of the result of the division. The other part we can get using a different operator called the remainder operator, or the mod operator. We use the percentage sign to signify that operation. So 4 mod 2 is the way we read this expression, and the result is 0. There's no remainder for the division 4 divided by 2. When we divide 2 by 3, the remainder in this case is 2. And when we divide 5 by 3, the remainder is 2. So again, as a review, we can think of 5 divided by 3, rewriting that as 1 2/3. When we do 5 divided by 3, we get this whole number 1. When we do 5 mod 3, we get this 2, the numerator of the fractional part of the result. So when we do 7 mod 3, we get a 1, because that expression could be rewritten as 2 1/3. We get that 1. Now that we've worked with these operators separately, let's combine them into expressions. We'll add 3 to 4 and subtract 5. And the operations are performed or applied from left to right. 3 is added to 4, and then 5 is subtracted from that result. Next, let's add 4 to 5 and multiply by 3. In this case, the order of operations dictates that multiplication should be applied first, followed by addition. 5 is multiplied by 3, and then that result is added to 4. The next expression will use a negative number. So this minus sign that we used for subtraction is also used with a single number in order to mean negation. We'll take negative 10, multiply it by 3, add 5, and take that to the power of 3. The order of operations will apply as follows. 5 will first be taken to the power of 3 because exponentiation has the highest precedence. Then over here, the negative sign applies to the 10 first, and the result, negative 10, is multiplied by 3. Finally, these values are combined using the addition. Just like in regular math, we can override operator precedence using parentheses. I can have the expression 4 plus 5 evaluate first before multiplying the result with 3. Similarly, I can decide that I would like the addition to happen first in the second expression we looked at by using parentheses to have it evaluate first. Up to this point, every instruction that we gave to Python yielded a result. For example, when we asked Python to evaluate the expression 2 plus 3, it gave us the result 5. That's because the expression 2 plus 3 follows the syntax of the Python language. Syntax is the rules that specify which combinations of symbols are legal, and 2 plus 3 is a valid expression in Python. The expression 3 plus, or the combination of symbols 3 plus, is not valid syntax. So when I ask Python to evaluate this expression, we get an error. This is our first syntax error, and we'll see many more throughout the course. So Python does not understand what to do with that combination of symbols, and it can't give us back a result, so instead it gives us an error. Another combination of symbols that will result in a syntax error would be to just use the exponentiation operator on its own without providing any operands. We can also write an expression like the one we just saw, only instead of having an opening and closing parentheses, we just include a closing parenthesis. That will give us a syntax error. If we include an opening parenthesis but no closing, then we end up with a different situation. When I hit enter, nothing happens, or it looks like nothing happens. That's because Python allows instructions to span multiple lines, and when we hit enter, it's waiting actually for the closing parenthesis. Until I give that closing parenthesis and hit enter, then the expression is evaluated. In addition to syntax errors, we'll also encounter semantic errors. Semantic errors occur when the meaning of a particular expression is invalid. So for example, the syntax of 2 plus 3 is valid. that is a valid combination of symbols. And the meaning, or the semantics of that expression, is that 2 is added to 3. So this is fine. 4 divided by 0 is valid syntactically. We're able to use this combination of symbols. However, the meaning of this expression is invalid. It's not possible to divide a number by 0. And so we get a zero division error, which is a semantic error.